All right, starting chapter 3 today, you're going to produce your own Google Sheet that has two sets of quantitative data, calculates the correlation coefficient, displays a scatter plot of the data, shows the least squares regression line, and displays the equation for the least squares regression line. So a great place to do that is this familiar website that is a random sampler. So I'm going to go out and find two sets of quantitative data. Let's keep it small. Let's keep it sample size 10. And let's do high schoolers. You can choose your determination how you like. And so what you're looking for is, what I'm going to be looking for is information of two variables that might be connected in some way. So there's many different variables I can choose. I'm going to choose foot length and arm span. I think that those are going to be connected in a linear way. As the foot length increases, the arm length will increase. So all I'm going to do is I'm going to grab these two columns, I'm going to Control C, and I'm going to paste this into a Google Sheet. In my Google Drive, I'm going to create a new Google Sheet, and I'm going to paste that information into my sheet. Okay, so what I took was I took some random people, 9 of them actually, and I have their foot length and arm span. The first thing I'll do is I'll create a scatter plot by just grabbing, highlighting the labels with the numbers. There's several places to go. You can go to Insert, or you can actually go to the toolbar here and insert a chart. Now it knows exactly what you're looking for usually, but what we're going to be plugging in is a scatter plot. So if it doesn't come up scatter plot, you can always change it to a scatter plot here. And the first thing I recognize is that there's a lot of white space. So I'm going to change the y-axis. So if I go to Customize and I do a vertical axis here, I can actually change the minimum value. So I'm going to change the minimum value to 120 and keep that at 200. Okay. And so what that does is give me a closer look at this graph. And so you might speculate that as the foot length increases, as does the arm span. All right. Thing we'll do is we'll put in a least squares regression line. Google Sheets calls this a trend line. So I'm going to edit this. We'll click the 3 dots and edit chart. And when I go to Customize, you're going to see a section called Series. And in this series, I can do many things. I can add a trend line. And so what this is it's something called a least squares regression line, which we'll get more into. But it is an approximation of the relationship between the two variables of foot length and arm span. All right, so for the correlation coefficient, I'm going to add another title. I've got a correlation, and I've zoomed in here so you can see the formula. I'm going to type in equals, and then it's CORREL. This is going to give me the correlation coefficient, and then I'm going to tell it A2 to A10. That's going to be my first array of numbers, and then I'm going to put a comma, and then B2 colon B10. So if I unzoom this, if I back out, you can see that it's registering the first two columns of this data. So if I press enter, then it'll give me the correlation coefficient. So that comes in at 21%. All right. So one thing we'll learn about the correlation coefficient is that it measures how strong the linear relationship is between these two variables. What you can see from the scatter plot visually is that it's not very strong, right? So a stronger relationship would be indicated by a higher correlation coefficient. The correlation coefficient can't be more than 1, but the purpose of this video is to help you make your own spreadsheet that has quantitative data, it has a scatter plot, it has a trend line or the least squares regression line, and it also has the correlation coefficient. All right, so here's another look at that formula when you if you need to look at that one more time. The final thing we need on this spreadsheet is the equation of this least squares regression line. So to do that, I'm going to say equals, and then I'm actually going to type in slope. You'll notice that this gives me the slope of that line, and I'm going to use the same array of sets. So I'm going to go from B2 colon B10, and then I'm going to comma, and I'm going to go A2 colon, and then A10. So I'm identifying the two sets of data. Notice I did the B column first. It actually is important you keep that order. They want the response variable first and then the explanatory variable second. And so if I press enter, I get a mismatch error, so that's going to happen. Oh, notice that this should be B10. And press enter. It's still, let's see, A2 to A10. Right, so you probably saw it before I did. I should have B2 here because B1 is a number, or is the label of the data. So here's the correct formula that you should type in to find the slope. All right, and so here is how I'm going to calculate the y-intercept. So I'm going to do equals. And once again, with the slope and y-intercept, you need to go in a specific order. They want the response variable first. That is the y-coordinate. So that's going to be the B2 colon the B10, and then comma A2 colon A10. And I'm identifying those two sets of data, and I get an error again. Let's see what I did wrong. Okay, so once again, this is you'll get it wrong a couple times, but what I missed was the intercept. So I'll do equals intercept, and then I'll do the response variable first, or the y-coordinate, followed by the x value, and I get a y-intercept of 156.3. All right, so here's a good look at your. So there is the correlation. This is the slope. And here we find the y-intercept. And so one thing about the correlation is it doesn't matter the order. I could have done the second column and the first column in different orders, and I still would have gotten the same correlation coefficient. All right, the final thing that I'd like you to do is interpret the slope. So when I interpret the slope, you might recognize that the foot length is the x value and the arm span is the y. Slope is change of y over change of x. So this slope is change of arm span over change of foot length. So if I can interpret this as 0.48 over 1, that would mean that for every 1 centimeter increase of foot length, the arm span increases 0.48 centimeters as well. Okay, so it's all about understanding that slope is change of y over change of x. And so in this case, it's the change of arm span over the change of foot length. So for every centimeter increase of foot length, the arm span increases by ½ centimeter. Here's another really good example that highlights some of the things we're learning in this section. So what I have for you is I have 9 hamburgers or 9 sandwiches from McDonald's. I'm looking at their total fat content and their calories. This is a great example of two variables that are very strongly linear related. In fact, their correlation coefficient, you can see there in blue, is almost 1. The correlation will never be more than 1. In fact, if these dots were a straight line, then it would be 1. But since these dots are so close to a straight line, the correlation coefficient is really close to 1, meaning there is a strong linear relationship between total fat and calories. In other words, total fat of a hamburger or one of these sandwiches can be used to predict the calorie level of each sandwich. And so when I calculated the slope and intercept, if I would interpret this slope, so notice that we're saying that calories is my y coordinate, total fat is my x coordinate. So in other words, the calories is the response variable. So it would be for every 0.06 grams of calories, we would increase 1 total fat. So the change of y over change of x. For every, in other words, in every increase of total fat, we're going to increase 0.06 grams of calories.